So for each element, loop syntax is designed to give you a simple, consistent access to every element in the array in read-only mode. But if you wanted to print array elements, for instance, backwards, starting from the last element and going back to the first element, this loop will not work. So let's bring back this list of double values, and let's modify this loop, or this method rather, the third time so that we can print the elements backwards. So I'll just copy and paste here and keep the original version, and here I will say print elements backwards. Okay, so let's do this. So what choices do we have? Let's start with doubles length. Okay, so we have index that would equal double length -1, because we always know that -1 is the index of the last element in the array. Then perhaps if this array size is 0, then we get 0 minus 1 will be -1. So perhaps we should change our condition to say that as long as our index is greater or equal 0, let's do this, okay? And then, of course, instead of incrementing, we have to decrement the index. And the rest should be pretty much the same. So we'll be printing, hopefully we'll be printing this array backwards. So as a result of running this main method and creating this prices array of doubles, we should see the printout. Once we say print doubles, we should see 3 lines with these different loops, and in the middle we should be printing everything backwards. Okay, so here it is. In the middle it goes from 50 to 40 to 30 and so forth. So this prints the array backwards. So these are general notes on using this version of the loop, and you can see that it works pretty well when we use it in a simple way. And so you can use it in some cases where read-only access is good enough. So right here, computing another average mean value, we take the sum, which we accumulate this time in this type of for each element loop. In case of prices, we just say price and loop through this array and apply the same formulas. Array class, arrays class, is a set of utility methods. They're all static methods that will take our array and fill it with something, or check the equality between the two arrays, like basically logically compare individual elements, and as long as there is the same number of elements and each element is the same, we can compare them and find out if they contain the same exact values. We can make a copy of an array. Okay, so if I wanted to make a copy of prices, what I would do here, I would say double prices copy, right? So I want a physical copy of an array, because remember, if I do something like this, okay, if I just say prices copy equals prices, I'm just creating a second reference to the same array. This is not going to automatically make a copy of an array. It's just duplicating the reference, just like it's duplicating the reference when we call the method, which is expecting reference to an array. So we're just duplicating this reference, but the object is the same. So if we need to have a real copy based on the array that we already have, then we need to call arrays, right? Arrays copy. and its name is copy of. Okay, so here we say copy of, and we provide the length right here. So here we can simply provide the length of the copy. We can say all of them, right? We can say prices length, like this. Okay, so this should give us a copy, and so now let's pass price copy to print doubles and make sure that it's the same. Of course, we need to make sure that we import it somehow. Once I was typing it in my source editor, there was a moment when it actually inserted the import automatically for me. So arrays, these utilities are located inside the utils package inside Java library. So anyway, just let's run this one more time, just make sure that nothing changed. Now we're passing a copy of the original array to this method print doubles. Okay, and it looks exactly the same, so everything is just fine. So this is how you make a copy of an existing array. Just use arrays utility method copy of. Another interesting feature here is a sort. Okay, so let's sort, for instance, array of our name list. So if I wanted to, I'll just scroll this up a little bit and just say public public static void print strings. Okay, print strings, and it will take an array of strings. And we'll use this for each loop because it's so convenient and simple to use. Okay, so this is our method. So we'll say for each string str in strings array. What we would like to do is just print, right? We'll just say system print line, right? Print line. I'll just print the names. Print this string. Okay, so very simple. So let's call print strings for our name list, and I'll just use it right here. Print strings, and we'll print this name list as a step in our program. Then we will call arrays and sort, right? We want to be able to sort, and let's sort name list. So that's pretty easy and quite nice. You see that the values here are populated and then repopulated actually the second time right here, not in alphabetical order, right, but in this arbitrary order. But after sorting, let's print them again. And let's take a look at the output. So you see that the first time, let's just actually indicate this beginning of printing. Let's use system out and print some kind of vertical line at the top of this print out. Okay, so that should be easier to comprehend. So here, this is an unsorted version of the array, and now notice that this is sorted alphabetically, okay, because the sort really took care of our name list, which is an array of references to strings, and so this worked quite nicely. So just remember that this is an extremely useful class. To remember that there are some really very convenient algorithms that you might want to use all the time with your arrays, and they're readily available for you, so you don't have to reinvent your own version of sort algorithm, or you don't have to write your own separate loop to copy elements, and there's a very simple way to compare the content of the arrays. But as always, I strongly recommend that you test your code, regardless what you think should be the result of this. Of course, every step of the way that you write your code, you have to find a way to test. Just basically stop what you're doing and check the result of pretty much every line of the code. You have to have some confidence in terms of what is really happening. And of course, experimentation in little programs like I'm writing here today is just the most, that's the only way really to learn how to program. And of course, part of that is testing. So just keep it in mind, make small incremental changes, and immediately compile and test. And the worst thing to do sometimes is to make a change in one place, like for instance, take this out, and then go to another part of the program and change something else, and then change something else somewhere else. And the syntax remains okay. You can see that you can still compile the code, but you're not testing. And suddenly you run into a problem that something doesn't look right, something is missing, or something is just giving you the wrong answer. And now you have a trouble, because you have to now trace and guesswork which of your changes could have potentially caused this problem. So you really have to minimize your changes, make them really tiny and incremental, and test and retest many times just to have some confidence. I think having confidence in your code is so much more important than making progress with, hundreds of new lines of code. Yes, you can write 100 new lines of code, but that just does not give you enough confidence to be sure that everything you did so far is correct, and you can use it as a foundation for your future coding.